Okay, so exponential, don't write this down. It's kind of in your book, but I'm just going to recap. So an exponential function would look like this kind of idea. 9 squared equals 81. Okay, that's an exponential. So what are the components of an exponential? 9 is considered the what word? The base. 2 is called the exponent. And 81 is the result. Okay? In this situation, we input the exponent and then we get the result. Okay? So in a graphing world, the input is considered which letter on your graph. You got two choices, X or Y. X, and your output is considered the Y. Okay, so in every exponential equation, okay, this would be the foundation of an exponential equation where your input is your exponent and the result is the output, the Y. Okay, but what kinds of things can I do to this now that I know all my transformation stuffs? I could do a as a timeser, right? I could put a B timesing in front of the X. I could put a C, or I could place a D on there, right? Okay? You secretly know all those things, even though you didn't know, you know. Okay, does that make sense? This is the basic, but I could do other things to it yet. Okay, so that's the gist of what I recapped in this. Okay, so here we go. We're going to graph 3 to the x. Okay, so base 3. So what I always start with is just these 3 things. I usually just do these 3 things. 3 to the negative 1. What happens with negative exponents? We talked about this last week. What happens to negative exponents? What do they do to numbers? Become fractions. We also learned this. Anything to a 0 is 1. And we learned that anything to a 1 is itself. Okay. And if you want, you can keep going, right? 3 squared would be 9. 3 cubed is 27. I'm probably not going to be graphing these. What would 3 to a negative 2 be as a result? No, no. 1 over 9. Because you flipped this location, right? Get it? See where it is coming from? Okay, so let's graph negative 1 comma 1/3, 0 comma 1, 1 comma 3, the next would be 2 comma 9, way up there. So what's the pattern going? We're going to be shooting up, 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 up. We're really growing. And what's the pattern as we go back here? This was 1/3. The next is 1/9. What's happening, do you think? Smaller, smaller, smaller. Do you think it'll ever go negative? No. So what kinds of things on a graph do you think it would make there? An asymptote. Okay, so the general rules, if it's just no transformations, that the anchor point is always 0, 1, because it doesn't matter our base, but if we do 0, x, y is 1. Asymptote is always y equals 0, unless there's a transformation. What's the only way I can move this asymptote? Which letter A, B, C, D would have to change? Which transformation would have to change for this to be different? Would I have to stretch it, compress it, reflect it, shift it left, right, up, down? If you move it up, down, it would change, right? And another point is always 1 comma base. So you could see I did the coordinate 1 comma 3. So that's my AAA rule. This kind of always happens. Okay, this time my base is 1/2. So I always start, this is just my basic here. 1/2 to the -1, 1/2 to the 0, 1/2 to the 1. Okay. Does anybody want to take a guess at what this becomes? 1/2 to a -1. What are you thinking? 2? Yeah. Because it changes locations. Anything to a 0 is 1. Anything to a 1 is itself. Okay, those are those 3 points. I can already kind of see the shape. If you wanted to do any more, for instance, what would 1/2 to a -2? What would that be? Did you think about being 4? -2 comma 4. Okay, so what's going on with this shape? It is decreasing. But we still kept to our rules. We still had 0, 1 as the anchor. We still had a y equals 0 asymptote. And we still had a coordinate 1 comma the base, which is 1/2. Okay, so I'm going to write a rule. You ready? If the base is less than 1, if the base is less than 1, what goes on with your shape? It will decrease. Some people use the word decay. So if you ever see that word, that's the same thing. It's decaying. So it's like population. Today, this is our population, and then tomorrow it's half, and then it's half, and then it's half, it's half. Versus this, if the base is greater than 1, what do you think will happen to the shape? It'll increase or it will grow, right? If you triple the population, triple, triple, it'll grow, grow, grow. If your base is 1, you're going to have a straight line. Because 1 to any exponent is just going to always just be 1, 1, 1, 1. You will not run into that because it doesn't. Okay. Next. Okay, so in this question, my base is 2. My base is 2. So here's what I'm going to do. I'm always going to do 3 coordinates. And I always do those three. I go -1, 0, and 1. So this is a half, this is 1, and this is 2. Okay, do you want me to graph that, or are we okay just to skip right to the last graph? This, yeah. Should I just graph it? -1, half, 0, 1, 1, 2. Okay, it's growing because the base is 2, so I'm growing, right? I'm increasing. Okay, what kind of letters do we have? So your options are A, B, C, or D. This is a C, and this is a D. You see the placements of where those are? Okay. How do you apply them? You do x subtract 3. Remember that formula? I'm going to write this whole formula out for you in case you forget. I told you you can never forget that. It just keeps going on forever, right? And I'm going to do a y minus 1. Okay, so these were the 3 coordinates you did. -1, half, 0, 1, and 1, 2. So the coordinates, you see where I'm getting the coordinates, right? Exponent, result. Exponent, result. Okay, let's do this and this. I'm going to rip through all the x's. I'm going to go subtract 3, subtract 3, subtract 3. Now I'm going to go through all the y's. I'm going to subtract 1. What's a half minus 1? Negative a half. 1 minus 1, 2 minus 1. Okay, so do you see the shape? And there's something different about my asymptote. Remember where my asymptote should have been? Over here. What happened to it here? It went down 1. Okay, so there was a new asymptote. So some questions might just say, what's the equation of the asymptote? Okay, that's what's happened. Okay, do you see this? It moved left 3 and down 1. You see the transformation physically. Find the y-intercept. So what is the definition of a y-intercept? Where x equals 0. That's the definition of it. So do that. See there's an x right there? Make it 0. So there's a 0 in place of where I could see an x. So this would become, what is 2 cubed? You should know that without a calculator. 8. So my y-intercept is at 7. Would that physically make sense? If you put a 7 right there, does your graph look like it would go there? No. Okay. That's it. No, it's not. Yes. No. Yeah, it is. Okay, I'm going to do some in your book, though, with you. Let's find one that looks... Okay, so I'm on page 4, number 14. So given the graph of this, I'm going to graph this. So can you identify the base? Look and say, what's the base? That's the first thing you should do. Base is 4. The base is 4. The exponent stuff is only applying to the 4. It's not anything to do with the 2. The 2 is going to be an afterthought. So let's talk about 4 to the negative 1, 4 to the 0, and 4 to the 1. So I'm going to take a few exponentials out of the base 4. So that's a 1/4, 1, and that's a 4. Okay, so my coordinates would become exponent, comma, results. Exponent, comma, result. Right? Input, output. Okay? It was actually already graphed for you. So that's that graph. So you see my 0, 1, 1, comma, 4. Okay, going back here, what letter do you have? A, B, C, D stuff. A, C, and a D. Okay, so write me a math formula with A, B, C, D stuff in it. What are you going to do? So X will have to get a add 3, because that's just going to move it right 3. And you're going to go 2y plus 1. See, all that stuff is the exact same as last units, right? Okay, so let's go all x's. Run them all through, add 3. Add 3, add 3, add 3. Good? All new x's. All your y's, I need you to double them and then add 1. I'm going to start at the bottom here. 2 times 4 is 8. 1 more is 9. 2 times 1 is 1. Plus 1, I'm up to 2. 2 times a, well, what? 3. 3? Is that what I'm supposed to be at? 2 times 1 is 2. Plus 1 is 3. Is that better math? And 2 times a quarter, half, plus 1 is 1.5. So I need you to graph me these 3 coordinates. Okay, your asymptote, you should know where to put the asymptote before I kind of sketch it as well. There is a shift up one, so my asymptote will be at a height of 1. What am I doing, guys? Oh, did I do 2.5? Oh, this is this big epic fail here. There, 1.5, I can count now. 1.5. Okay, so do you see the things? Do you see the vertical stretch? Here's a vertical stretch. These two coordinates on this graph are a distance, a space of 3. Now, if I look at them, that coordinate to that coordinate, they're actually spaced out 6 apart now. Does that make sense? 3 apart, 6 apart? Because they stretched in space by 2. I moved it right and I moved it up.